the way to rethink networking is to think of networking as a secure data exchange. So it's really all about moving data and not about moving packets anymore. Darren, welcome. So great to have you here. Last time we were chatting, it was back, I think it was in New York, with Broadcom, when we were talking about the whole kind of Ethernet and InfiniBand, as an infrastructure component for AI.
It's been a little over a year now, so it's great to be back. So thanks for having me.
Awesome, it's great to have you. So, what I love talking to you because you're doing customer engineering, and so you're interacting with a whole bunch of customers, and you get this really great view, kind of state of the art, in terms of what's possible, and then also what's not working, as well. So I think that you always offer a really great grounding, in our discussion. So anyway, I'm looking forward to chatting with you.
Appreciate that. Thank you.
But I thought, what would be good if we started is to let everybody know a little bit about you.
Sure.
So your career path, like how you got to Arista, where you came from before.
It's been an amazing career. I could say that it's been networking almost 100% of the career. But I guess I started back in the day of I always say my career is like the OSI model. I started terminating Ethernet cables was the first thing that I ever did, pulling cable through the network. Worked my way up through the Novell network days, if you remember Novell.
For sure.
And then got into networking, right? Yeah. And so now I'm at Arista. I lead a large portion of the customer engineering organization, where, as you said, I get to engage with customers day in and day out. We build highly performant networks that, for AI fabrics, for the enterprise, for the cloud. Just a lot of great things that I get to do. So it's been a great career, and enjoyed leading the team, but also love the customers. That's the greatest part about it. So
I bet. It's like, actually, I think in any role that you're at, I think you need to stay close to the product and stay close to the customer.
Sure.
And if the further you go away from there, the less engaged you are in the actual running of the business. So it's great. So you're kind of like right there in the in the middle of things.
Sure. I mean, if I'm far away from the customer, I'm unhappy.
Oh my God, you in your role.
Right? And then the reality is, I joke with my team that working with the customer is my antidote for all of the other headaches that go on in life, because that's where you get the true message. You get the true, truly what's happening. Right?
Yeah.
So
for sure. Yeah, and that's actually one of the things I love about what we do here. It's that like even like this morning's sessions, it's like we had Sean Finnerty, from Merck, and. And Sean was just like so good because he just grounds.
Right.
It's not a hype session around AI. It's like, but they do talk about where they're using it, where they're getting 30% return, especially on coding, and application development, areas, and also and how AI has impacted their workflows and how they're delivering. So he basically has the infrastructure and the cloud infrastructure, and he has a big AI project as well. So how that's actually implementing or how it's impacting his customers, and his customers are the business units around them. So anyway, so I totally get it. Like when you talk, you get grounded really quick when you're talking to folks who are really the practitioners in the market.
Yeah, customers are great truth tellers.
Yeah.
They'll let you know one way or another how well you're doing or how not well you're doing.
Yeah, like awesome. where you have room for improvement.
Exactly.
Exactly. So all right, so let's tap into that.
Sure.
Right. So a couple of things. One around AI workloads. So a lot of AI has been focused around data centers, and it has been focused around GPU clusters and so forth. But then there's also for example, like Microsoft processed 50 trillion tokens, right? That was reported during their last quarterly call, and that was just in the month of March.
Right.
So we know that AI is now sprinkling itself into every major application, not even a major, every application that's out there. How are you seeing kind of AI workloads impacting infrastructure?
I mean, obviously, AI is we like to say that the GPUs are like the diva of the networking world these days. They demand everything, right? Meaning they demand perfection, right? And so obviously we build networks to be able to support this large east-west amount of traffic between these GPUs. We build networks to support more than that from the back end and the front end. And I think the interesting thing for me is that AI has changed the way you have to think about a network. It used to be that we were okay with networks, most of the time, as long as we got fairly reliable delivery, we were okay. AI networks don't allow that, right? You have to have everything working all the time. You can't drop a single packet. You have to have observability in ways that you couldn't see before. And I think that's really the cool thing about AI is I came up in the world at Arista with SDN, the software-defined networking, and this is sort of the next big thing that's happened to us in the networking space, to where we have to fundamentally think about networking different. And we continue to learn each and every day, right, on how we're doing that. There's things coming with UEC, which I'm sure we'll get into later, and some of the other aspects of it. But it's really about thinking about networking different and thinking about how Ethernet solves these problems in the AI world.
No, I'm totally with you. And I think like some of the changes that we've been seeing are, especially around the intersection of AI and cloud and those workloads. What those are doing, they're injecting different kinds of traffic patterns, processing, latency requirements that are really inverting the expectations of networks and how networks are to behave. So I think there's that's so we're in a space, frankly, that is really different, right? And I kind of liken this to like, we looked at like, back in the 70s, 80s, and 90s, we had north-south traffic mainframes. Then into current day world, east-west, that started in the 3-tier kind of data center, market. Then cloud, came, and then we saw a different center of gravity or data gravity going into the cloud. And so then we had kind of like little weirder traffic patterns, but it was still prominently north-south and also east-west. Now we're into Brownian motion. It's like the traffic patterns are all over the place. The latency requirements are extremely stringent. The processing is extremely, stringent. The timing, is stringent. It's a different world, that we're in, and so I think where my mind is going, and we've been starting to talk about this, is that the way to rethink networking is to think of networking as a secure data exchange. So it's really all about moving data and not about moving packets anymore. Right. And so, and then we need this exchange to kind of facilitate and orchestrate data flows and to kind of deal with that unpredictable traffic patterns and to prioritize that data movement, based upon a wide range of metrics, not just source and destination address, and be able to kind of make kind of forwarding decisions or path selection decisions like a millisecond time frame. So I think we really are in a fundamentally different kind of industry right now.
I mean, I think it's going to continue to change, right? And as our CTO likes to say, if the network ain't working, ain't nothing working.
That's very true.
And the reality is, it's if you're spending $1 billion on GPUs, you want them to be able to work 24/7, right, by 365. Like, you have no choice. Like, you've made this huge invest in it. And so I think for us, as we think about networking, it's not only how do we get access to the GPUs, but then how do we get the data? How do we use those models that we're training, right, from an inference standpoint? Are starting to talk about RAG and some of these other things where I'm pulling data from lots of different places, and if you don't have a performant network to get there, you're wasting time. Like, you're burning cycles, and therefore you're burning this investment that you made in these very expensive, very power hungry GPUs across the world. And so
it'd be interesting, kind of like, what is the overall cost associated with the network part? So if we think about kind of the GPU space, how much does the networking of that total system, but how much does the network actually impact the performance of that? If you look at number of tokens per second, token per revenue, any of those kinds of metrics.
Yeah, I mean, I think the best number I can give you is just based upon some of our larger AI infrastructures, about 20%, somewhere between 15 to 20% of the total cost of the system. When you're looking at GPUs, you're looking at data center costs, so about 20% of that is networking. And so it's a smaller piece of the overall puzzle, but
Yeah.
back to that's the one piece, kind of like if the cooling goes out of your data center is going to overheat and you're not going to be able to use it.
Yeah.
The network goes out, you're done too.
Yeah.
So
Well, that is interesting because like 20% of that could impact obviously all other 80%,
Sure,
you know, and
absolutely.
it does. And then I know we've heard interesting stat as well earlier today that 10% of power is consumed by the network, you know, as well in that infrastructure. So
yeah, I think that's probably certainly a statistic that you could look at. I think we're getting more and more efficient from a networking standpoint. You know, whether it's the some of the new LPO capabilities in optics, whether it's, you know, switches getting more performant in terms of, you know, we're talking at 1.6T is on the horizon. So I think some of that's going to continue to ebb and flow.
I would think,
But I think it's certainly it's not a very minuscule piece of it. There's significant amounts of power that the network drives, and there's significant amounts of value, obviously.
Well, it's material and it's on the critical path,
Sure.
you know, and also like, and I think the point is that 20% can have a huge impact on that larger investment
Sure.
that you're making. So you really have to have availability and reliability, scalability, all those kinds of things.
Yeah, I'd heard the other day, I was talking to one of my colleagues, and he said that a 1% power savings in the network would justify them buying, you know, a switch, right? So like 1%, like that's how small, you know, we're looking at how do we optimize this to, I can save 1%. Okay, I'm interested in saving that. And that allows them to then scale from, you know, let's say 100,000 GPUs to 150,000 GPUs. Like, I don't know what the 1% exactly equates to, but it allows them to scale greater. And that's the hyperscalers particularly are trying to squeeze every last dime that you can get out of that.
I would think so. You know, it's like it's a huge investment, you know,
Sure,
so
absolutely.
you want to, you know, if they weren't doing that, they'd be delinquent.
Yeah.
All right, so challenges. So I think we've been kind of talking about some of the challenges, you know, but from an empirical perspective, like, you know, you've been in a lot of the hyperscalers and also like the large AI data centers that are being built. So what are you viewing as like some of the major challenges?
It's interesting that you know, I never thought that I would be in networking, which is kind of like the trades of IT, right? So it's very important, right? We deliver plumbing for the most part. You know, one of the biggest challenges we see in the AI data centers are cabling.
Yeah.
You would think that it would be all of these other high tech things, but cabling becomes a challenge because there's so many optics.
Yeah.
And, you know, a single speck of dust on an optic could cause that optic that's running at 400 or 800 gig to go down. So certainly that's a challenge. You know, you see some other things with regards to how we're distributing traffic flows, right? So how do we spray traffic across the network? How do we utilize all of these links in the most effective and efficient manner? Because again, if you have any type of head of line blocking to where you're dropping packets, a drop packet means that a GPU gets starved, job breaks, right? So that's, you know, game over at that point.
Game over. Yeah.
And then I think
especially if it's a training session.
Yeah, absolutely. If it's a long running training session and you're training across 20, 30, 50,000 GPUs and you got to restart that job and that job's been running for 12 hours already, it's a wasted 12 hours. Right?
It's huge.
And that gets to kind of the third thing that we see in the AI space, in the AI data center space is visibility, right? So with Nickel and some of the different, you know, control languages that we have to deal with, how do we make them more network aware, right? Because when you spin up a job, it decides what nodes it puts the job on. It decides how it's going to distribute this workload. Well, it would be nice to know that GPU 2110 is actually having a network connection problem because I got a bad cable to it. And if I send a job to that GPU, I'm going to likely have a bad outcome.
Yeah.
So I think these are some interesting things that we're working on and trying to solve is how do we make the network more aware of the AI applications so that when we kick off a job, we could do a test across the entire networking infrastructure and say, okay, all the GPUs associated with this job are good to go, right? Or, you know, this particular segment is showing, you know, high FEC rates or high error rates, and I need to go make sure that I don't use that GPU in the job so that I ensure the overall job integrity.
Makes sense. You know, all right, so great. So I think I got, I think some of the challenges, from you, and you're right, like the cabling is like massive,
Yeah.
when you're connecting up 100,000
Sure.
GPUs in a small amount of space, that's a huge number of connections because they're all, well, what's the word I'm looking for? It's a full mesh, non-blocking,
Right.
configuration. So you have n to like, well, what, the n minus one over n kind
Yeah.
of connections,
Right.
going
Yeah.
on.
Yeah.
So you have a lot of connectivity, going on. So, and that's a very manual process,
Sure.
as well, prone to error. Okay.
Yeah.
Um, what about major success stories? Where do you see like maybe a deployment that you're most proud of?
Yeah, I mean, I think there's a couple, and we obviously can't talk about customers, so I want to speak in generalities.
Sure.
But I think one of the ones that I'm most proud that we've been involved with is a large scale GPU deployment. The network, for this particular network, it was more, hey, we want to do a rail based system, right? So they wanted to build 8 rails across the network, start with 4 and maybe go to 8. And you're talking thousands of switches in this equation. And to be able to, you plug everything in and you wait for that day for everything, like, okay, everything's ready for use. And then you run the first job on it and then you find the challenges associated with it. Oh, well, this cable's bad or that thing's. And but the cool part about it wasn't so much that we designed it, like you design the system and then you deploy the system and then you've done your due diligence. You know it's going to work, but you don't know what new problems you're going to find. But the really cool thing about that system that I thought was awesome is we were able to use the telemetry that we have from in Arista's world from EOS and CloudVision to visually display, this is the health of the system. This is how the flows are moving through the system. These are, how the jobs are running. And to be able to tie that to a job and go, hey, this job ran for 30 minutes from, this time to this time, and be able to say, here were the nodes involved in that, and here's how those nodes performed, and to see the traffic patterns. It's just something cool about watching a chart go from 0 to 100 back to 0 when the job is done. So you're making a difference in somebody's business when we do that. And so that combined with the partnership with the customer has been amazing, right? Just having the customer say, listen, we've never run this clean before. We've never been able to go from 0 to 100 this fast before. And it gives you a sense of pride, to be quite honest, but not just building something of very large scale, but also building something that's very successful and continuing to be successful. We continue to see them grow and add more and more and more to it. I'm anxious to see what it grows to in the end.
What was the outcome of the actual AI app that they were running?
In terms of what were they trying to solve?
Either they're trying to solve, or was it an LLM, or was it?
I mean, this was very specific to a customer's business. So they were trying to solve a specific business need from sort of this.
Which industry?
Autonomous side of things. I'll leave that one alone. So I think it's kind of autonomously, how do we accomplish a task, right? And so I think the cool part about this was, they're constantly running these training jobs. And then to be able to see the training jobs build the foundational models that they can then go leverage in another space was really neat. So
yeah, okay. All right, so future.
Yeah.
All right. We know that this space is growing exponentially. It'll increase by a factor of 10 in 2 years. Another factor of 10. So factor of 100. By pretty close to 2030, it'll be 2029, something like that. Which means that, if we extrapolate, if those numbers are correct, which they seem to be, then by 2030, we'll see, GPU clusters of 5 to 10 million and, power consumption 10 to 100 gigawatts, what kind of world does that look like to you?
Yeah, I mean, scale is always been a challenge, right? And obviously we're continuing to go faster, which I think is going to be better, right? But the GPUs are also going faster. So, we're at 800 gig today, heading towards 1.6T pretty close, pretty soon. Can we go to 3.2T on a single port? I think those, you're starting to get to the edge of what physics can handle. And it's requiring us to think differently about how we build systems, how we interconnect those systems. Simple things like trace length on a system starts to matter that you didn't think about before. The amount of power and cooling that you need in a system because we're so dense. So I think that we have solved the scale out problem. Like I think we're pretty sure that we can just grow wider and wider and wider, assuming you can get power, assuming you can get all of the other things.
Power
right?
is a critical path for sure.
Yeah, and I think that's what one I didn't mention earlier because it's less in my wheelhouse. But power is a huge challenge for these AI data centers. So as we start to scale past 250 to 500,000 to 1 million GPUs, scale out starts to matter. Now, there's the whole industry as a whole is working on the scale up side of things as well, as we think about liquid cooled, as we think about these really, really dense systems. You're talking, 300 kW for a rack. Like the really dense systems are going to start to come online. At the end of the day, whether we do scale up, you still got to scale out even with scale up. You're not gonna scale up, a half or 500,000 GPUs or a million GPUs. And so I think for us, we'll see kind of the combination of the two. You'll see scale up. Scale up is still going to have to scale out as we build larger. That's where we start to see higher speeds where, it's X by 1.6T or, you get beyond that. And I think that we'll continue to see that growth happen over the course of time. I think there'll be new technologies that we'll start to see implemented. I mean, obviously there's the whole argument right now around CPO, LPO, different lower power optics capabilities. Whether we co-package it, whether we do it on the same silicons or not. That'll be an interesting thing that we see kind of play out over the next few years. Supportability of those, I think, is going to be a big question. But from a scale standpoint, I think we'll see the kind of the scale up side of things with UAL and some of the other stuff. And then we'll continue to scale out with traditional Ethernet. I think the one thing that's without question is that Ethernet has won this war, right? And it's InfiniBand's still hanging around trying to do the smaller clusters. But there's no doubt in my mind that if you want scale up, scale out, it's going to be Ethernet, and it's going to be Ethernet in a major way. So.
Yeah. Okay. All right. Great. Let's leave it there.
Okay.
That was great. Darren, thanks so much for joining.
Awesome.
It's great to get your perspective on the industry, as well. So great. Thank you.
Thank you.
You're welcome. Great.